Welcome to this explainer. Okay, so today we are diving headfirst into a literal cosmic detective story. We're unpacking a really fascinating mystery from a recent paper in the Astrophysical Journal. And honestly, it's one that might completely challenge our classical understanding of the universe.
To really grasp this, we have to start with this wild, enduring puzzle. A staggering 85% of the cosmic matter in our universe is just missing. So, while the normal visible matter, the stars, planets, you, me, makes up just 15% of what's out there, the rest is this totally elusive stuff we call dark matter.
Which brings us to Section 1, the enigma of dark matter, the ultimate cold case of the missing matter.
Now, by definition, this stuff emits and absorbs absolutely no electromagnetic radiation. None. That means it's completely 100% invisible to all our telescopes. We really only know it exists because we can see its undeniable gravitational pull tugging on galaxies. But since it doesn't interact with light at all, it acts like a massive invisible ghost lurking out there, and figuring out what it actually is remains one of astrophysics' biggest cold cases.
But recently, things got interesting. Let's look at Section 2, LIGO's unexpected signal, a seriously anomalous clue. Just when this cold case felt permanently stuck, the LIGO observatory picked up something super weird. Since 2015, we've been using gravitational waves, those literal vibrations in space-time that Einstein predicted, to probe invisible phenomena, like the collisions of incredibly dense objects. Well, LIGO recently recorded a very curious signal indicating a highly dense object merging out in the dark. But here's the catch. Its profile doesn't match what we'd expect at all.
To put that into perspective, let's compare. On the left, you have your standard stellar black holes. These are born from the explosive collapse of supermassive dying stars, right? So their mass is always significantly greater than our sun. But then you look at the object involved in the recent LIGO anomaly on the right. Its mass is actually less than our sun. That is a massive problem. It completely breaks the established rules for how standard stellar black holes are supposed to form.
So what on earth could this impossible object be? Let's move to Section 3, Primordial black holes. The new prime suspect.
To explain this anomaly, researchers are looking all the way back to the Big Bang. The idea is that right at the beginning, extreme density fluctuations could have crushed tiny pockets of matter into miniature black holes. Now, Stephen Hawking actually theorized these ancient objects heavily back in the 1970s. Fast forward past our first gravitational wave detections, and now this modern LIGO detection of a sub-solar mass object perfectly matches the profile of Hawking's theoretical ancient objects.
So, just imagine this. Could our elusive dark matter actually just be a cosmic swarm of these tiny ancient black holes? We aren't talking about the supermassive giants at the centers of galaxies. We're talking about objects born mere fractions of a second after the universe began that could have the mass of a planet, or, amazingly, even just a tiny asteroid, swarming silently everywhere.
Which leads us to Section 4, solving the cosmic mystery. Is this the elegant solution we've been searching for?
Well, think about it. These primordial black holes have a massive gravitational pull, but they completely ignore light, making them entirely invisible. That perfectly matches the profile of dark matter. If there are enough of them out there, they would elegantly explain that missing 85% of the universe. And the best part is, they do it without requiring us to invent any exotic, unproven new physics.
But science requires meticulous patience. The researchers from the University of Miami behind this study note that their calculations show these specific anomalous events are pretty rare, so we really need to detect more of these signals to actually confirm the hypothesis. The great news is that the upcoming space observatory LISA is going to offer far greater sensitivity, which is exactly what we need to catch more of these faint gravitational ripples.
So, the big question we are left with as we look to the sky: will LISA finally reveal the invisible to us? Will it unveil these ancient ghosts and solve astrophysics' greatest mystery once and for all? The universe definitely holds its secrets closely, but we are getting so much better at listening. Thanks so much for joining me for this explainer, and keep looking up.